I have 3 vials, created in the last episode, which will represent 3 different compounds: p-bromoaniline, benzoic acid, and naphthalene. These 3 compounds all have a unique value of polarity, and when mixed together, they can be separated by this value. The technique used to do this is known as thin layer chromatography, or TLC for short. To set up each sample, I'll take only a milligram or 2 of each solid and put each of them in a vial. For the solvent, I will use CH2Cl2, which is methylene chloride, or known as dichloromethane, which has 3 characteristics we need for TLC: a low polarity, the ability to dissolve the substances fully, and it has a low enough boiling point to evaporate. This will allow us to dip the tip of a capillary tube into each of the vials, taking a small portion of the dissolved sample to be tested. Only a few drops are needed to dissolve the substance. Here, I'm gently shaking each of the vials and lightly flicking them to get the solid to dissolve. I will also be using the mixture of my 3 compounds from the first video on liquid-liquid extraction to act as a 4th sample. All 4 of these samples will be placed onto something known as a TLC plate, which you'll see a little later. Now that the samples are ready, let's make some capillary tubes to use for the samples. Here we have a Bunsen burner, which will act as the flame that will allow us to pull the pipettes we're using apart and make the tip of the tube as small as possible. Once you have the Bunsen burner out, attach its tube to the gas tube and turn it to start the gas flow into the Bunsen burner. Use a flint lighter to get the flame to start. Hold it over where the flame will be and strike with force and pressure. It may take a few tries, but once it works, you'll see fire coming out. My arm gets in the way of this, but in short, to make the actual tubes themselves, take a glass pipette and hold each end with the tips of your fingers. Then, put the thin end of the glass tube over the flame. Once it softens up from the heat of the flame, which will be for about a few seconds, pull the tube apart in opposite directions. This will stretch the tip out to where it is incredibly long and thin. This will also take a few tries, so get your instructor's help if you're struggling. The reason we do this is because it's perfect for TLC spottings. We want the spots on the TLC plate to be as small as possible, and you want to make about 5 to 10 of these, depending on how many samples you're spotting on your plate. Now, for what the TLC plate actually looks like. You'll notice that I've already marked where I want my 4 samples to go with a pencil. Try to write with very little pressure so you don't damage the thin layer of silica. You do not need a lot to draw on it. The line here is where we want to leave our solute, hence the 4 dots for each of my 4 samples. So what I'll do here is lay the plate flat on the bench, and I'll take the tip of the pipette and gently dip it inside of each of the sample vials. You'll notice that when I spot the plate, I'm very careful to not oversaturate the spot. The liquid you see coming out is quite a minuscule amount, and for each of these samples I'm using entirely different pipettes because you don't want to have any sort of cross-contamination when it comes to each spot that you create. If you wish to use a single capillary, you need to rinse the capillary with acetone a few times between samples. While I'm still spotting the plate, I'll explain how this works before you get to see it in action. The TLC plate has a layer of silica gel on top that is very polar, so depending on what kind of solvent you use, the solute you've spotted onto the plate will move a certain length up the plate as the solvent is absorbed and runs up the plate. More polar solutes will be further back towards the original spot that it was, and less polar solutes will travel with the solvent. The phase in which the solute is being spotted onto the plate is known as the stationary phase, whereas the solvent is the mobile phase or eluent phase. The solvent in question that I'm using here is 40% ethyl acetate and 60% hexanes. This is a decently polar solvent, as ethyl acetate is very polar and hexanes are nonpolar. You can experiment with different percentages of ethyl acetate and hexanes to see different types of results. Once you pour the solvent into the beaker you're using, you should put the TLC plate in and then cover it immediately with a watch glass or lid to prevent the evaporation of the solvent. Here's a cool little time lapse of the solvent running up the polar TLC plate. Once the solvent almost reaches the top and stops running entirely, take the TLC plate out and quickly mark a line where the solvent stopped on the plate. This will indicate the length in which your solute traveled. Now, to actually see the spots and how far they've traveled, we're going to use a UV light and hold it over the TLC plate. Keep in mind that less polar substances travel farther. And there it is! You'll see that there are multiple spots for the sample of my mixture, which is exactly what we want to see. Each compound traveled a different distance, and there are 3 spots in the mixture that line up with each of the 3 sample spots from individual compounds. To more clearly illustrate this, I'm going to mark off camera each spot by tracing by hand with a pencil and then go over it once more. Now that I've marked all the spots and labeled each sample spot, you can see that the benzoic acid spot and the p-bromoaniline spot overlapped a bit when together in the mixture sample, but under the UV light, the sample spot for p-bromoaniline turned yellow, so you can actually see that the benzoic acid traveled slightly farther. Naphthalene's sample traveled almost all the way with the solvent, indicating that it is less polar than p-bromoaniline and benzoic acid. The final thing we can do is calculate the retention factor, which is the distance traveled by the solute in centimeters divided by the distance traveled by the solvent in centimeters. This is why we marked lines earlier, as the solvent path does not show up on the UV light. When we measure how far the spots travel, we want to measure from the middle of the spot. Here are the retention factors for all of the spots. Thanks for watching, and I'll see you in the next video.